Guys, today I will discuss the behavior of reinforced concrete in 5 stages. The behavior of concrete behaviors of concrete are mainly of 3 types. Okay. Number 1, uncracked section behavior. Number 2, cracked section behavior. Number 3, it is mainly 2 types. Okay. Cracked section behavior, it is of 2 types. It is cracked section number 1A, elastic behavior. B, inelastic behavior. Okay. Inelastic behavior, it is of 3 types. Number 1, balanced failure condition. Number 2, over reinforced condition failure. Number 3, under reinforced or ductile failure behavior. So firstly I will discuss the uncracked section behavior. It is very simple. If we take a concrete section, okay, and the load is applied on this face, and then suppose that this is the beam, we have applied P load, and it will bend like this. Okay, and suppose that a section is this one. Okay, now what will happen, if you calculate the stress, suppose this is y1 and this is y2, okay, then this fiber will be in tension and this fiber will be in compression, and the stress calculation formula is m sigma t equal to m y2 divided by I, where I is the moment of inertia about the neutral axis. Okay, now if this stress sigma t is greater than is less than fr means 7.5 lambda root over f prime c, and it is known as tensile strength or modulus of rupture of concrete. Okay, the stress distribution is this will be m y1 divided by I, and it is compression, and this is sigma t equal to m y2 divided by I, and you see that m divided by I into y2, and this resembles to y equal to mx. That means it is linear. Okay, the stress distribution over the cross section in both neutral axis, above the neutral axis and down the neutral axis, is linear. So it is called uncracked section, because in the extreme tensile fiber the tensile stress is less than the modulus of rupture, that is the tensile strength of concrete. Okay, since it is less than the tensile strength of concrete, so this fiber will not crack, but as the stress approaches to modulus of rupture and become equal to and the stress becomes equal to modulus of rupture, the concrete fiber will crack. Okay, and then the uncracked section behavior comes into play. Second number is uncracked section behavior. Cracked section behavior comes into play when fr equal to 7.5 lambda root over f prime c. When fr is less than sigma t, then the concrete section will crack the tensile zone. Okay, now we know that when concrete is cracked, it will no longer be able to take the tensile stress. Okay, then what we will do, we shall introduce tensile steel in the tensile zone. Okay, now Crack section analysis is done in two stages. Number one is elastic, or another name is working stress analysis, working stress behavior, working stress behavior. Okay, sorry, elastic, and based on this elastic behavior, based on this elastic behavior, working stress design is done. Okay, now why we call it elastic stress design, elastic behavior? Because the tensile stress of tensile steel is not allowed to cross the Fy, that is yield stress. Okay, and the compressive strength above the neutral axis in the compression zone of the concrete is not allowed to cross the ultimate the specific compressive strength of the concrete. Okay, that is suppose that it is steel and it is denoted as Fs, and this is Fc. Okay, Fc is equal to 0.45 F prime C. Fc is taken as Fc equal to 0.45 prime C. We see that it is far less than yield specific compressive strength of concrete, and Fs is taken as 0.40 Fy. Okay, that is the allowable stress to keep it in the safe zone, so that it is far less than yield stress, okay, of concrete. So the so if we see the stress strain diagram of steel, okay, we will see it will look like this. Okay, this is strain and this is steel stress. Say this level is Fy. Okay, and we see that this portion is linear before Fy. Okay, and the Fs in the working stress design or elastic behavior stage, the during design, the Fs is taken as 0.40 Fy. That is why it is called elastic behavior. Okay, that we limit the section in such a way and design and fix the proportion of the steel to the concrete area in such a way that Fs will not exceed Fy, and the stress of compressive stress of concrete will not exceed F prime C. Okay, That's why this is called elastic behavior analysis, and based on this elastic behavior, the working stage design method is flawed. Okay, now the second design method is inelastic design. Okay, inelastic design. Okay, in this the behavior the concrete behaves, the section behaves, the reinforced concrete behaves in three ways. Number one is balanced section, balanced behavior, balanced failure condition. Okay, balanced failure condition. In this case a prime c fc equal to a prime c. Okay, and fs equal to fs less than fy. Okay, that means at failure time, okay, the concrete will fail, the concrete will fail before sorry, this is balanced failure. Sorry, it will be balanced failure. F is equal to Fy. Okay, the concrete will fail simultaneously simultaneously with the steel yielding. Okay, that means at the same time, as soon as the steel reaches its yield stress, the concrete will fail. Okay, the concrete will crash. That means when epsilon t equal to 0.002, epsilon c equal to 0.003. Okay, epsilon c equal to 0.003. If you look at the strain diagram, then at balanced failure condition, this will be 0.003 and this will be 0.002. Okay, number 2, over reinforced failure. Over reinforced failure. In this stage, in this failure condition, the concrete will fail before the yielding of steel. Okay, that is epsilon c equal to 0.003 when fs is less than fy. Okay, that is, this is fc greater than f prime c, and this fs is less than fy. Epsilon t equal to epsilon t less than 0.002. Okay, and epsilon c greater than 0.003. This condition is called over reinforced behavior, over reinforced failure condition of beam. Number 3, this is our most awaited failure, this is our desirable failure condition, that is under reinforced beam. Under reinforced beam or ductile failure of beam. In this case, fs will be far greater than fy when fc equal to f prime c. Okay, and fc equal to f prime c, that is, the concrete will, the steel will yield before the crushing of concrete. Okay, that is when epsilon t is far greater than 0.002. Okay, then epsilon c equal to 0.003. Okay, this condition is called under reinforced failure condition, and during design the minimum epsilon t is 0.004. এই 0.004 এর নিচে আসতে পারবে না আমাদের, বুঝতে পারছেন? এই 0.004 এর নিচে কোনো মতেই আসতে পারবে না। এসিআই কোডের লিমিট এবং বিএনপিসি এটা লিমিট করে, ঠিক আছে? এটাকে বলা হয় ম্যাক্সিমাম পারমিসিবল লিমিট অফ single reinforced beam. Okay, if this is crossed, then doubly reinforced beam is designed. Okay, and recommended for tension control section. এখানে আরেকটা বিষয় আছে যে এই যে আন্ডার রিইনফোর্সড বিম ফেইলারটা, ঠিক আছে, এটাকে আবার 3টা ফেজে ভাগ করা হয়। আন্ডার রিইনফোর্সড এই যে ফেইলারটা, ঠিক আছে, এটাকে আবার 3টা ফেজে ভাগ করা হয়। 1 নাম্বার হলো কম্প্রেশন কন্ট্রোল। 2 নাম্বার বলা হয় যে ট্রানজিশন কন্ট্রোল। 3 নম্বর টেনশন কন্ট্রোল।  এখন কম্প্রেশন কন্ট্রোলটা কি? when f prime c fc equal to a prime c, then a prime c, then epsilon t equal to 0.002. Okay, 0.002. Number 2, compression controlled, transition controlled, okay. In this case, when a prime c equal to fc, then epsilon t will be greater than 0.002 but less than plenty greater than 0.005. ওকে, এটা হলো ট্রানজিশন কন্ট্রোল। এখন 3 নাম্বার হলো যে টেনশন কন্ট্রোল। ঠিক আছে, টেনশন কন্ট্রোল সেকশন। এক্ষেত্রে কি হবে, এপসাইলন টিটা গ্রেটার দেন 0.005 হবে যখন এপসাইলন সি ইকুয়াল টু 0.003। এই হলো বি পার্ট। এগুলো হলো কংক্রিটের বিহেভিয়ার, আমরা সংক্ষেপে আলোচনা করছি। ঠিক আছে, আশা করি এটা আপনাদের জন্য অনেক হেল্পফুল হবে। এখানে আমি খুব সিম্পলি ম্যাথমেটিক্যাল এক্সপ্রেশনের মাধ্যমে বোঝানোর চেষ্টা করছি যাতে করে আপনাদের বুঝতে সুবিধা হয়। থ্যাংক ইউ ফর ওয়াচিং। আসসালামু আলাইকুম।